G1000. As we progress through the digital age, more and more pilots are transitioning from the traditional analog instruments that we just covered and moving toward digital instrument displays. This new setup is referred to as a glass cockpit. One of the most popular glass cockpit systems available on the market today is the Garmin G1000. Embry-Riddle utilizes the G1000 in all of its Cessna and Diamond training aircraft. This system integrates all of the various flight instrument and navigation and communication equipment that the pilot interacts with and displays them on the LCD screens in a clean, unobtrusive manner. This simplifies aircraft operation and navigation and allows the pilot to focus only on the most pertinent information. The G1000 setup typically consists of two display units, one called the Primary Flight Display, or PFD, and the other one called the Multi-Function Display, or MFD. Between the two displays is an integrated communications panel. This panel, along with the two displays, allows the pilot to interact with the system through buttons and dials. The rest of the system is contained behind the scenes and consists of various computers and components working together to control the system. The PFD displays the basic flight instruments we have just become familiar with. While the display of the instruments is a little different from that of the old round dials, it is still relatively easy to understand what is going on. In the center of the screen, you'll find an attitude indicator. This instrument looks almost identical to that of the original instrument. The big difference is that the horizon bar in the background takes up the entire screen. This really places the necessary emphasis on the instrument so that the pilot can still see it when it's focusing on a different instrument. To the left of the attitude indicator is the airspeed indicator. Instead of a dial, this instrument is displayed in a vertical tape format. At the bottom of the tape is the airplane's true airspeed. The G1000 calculates this automatically based upon the outside temperature. The right side of the screen is home to an altimeter and vertical speed indicator. Like the airspeed indicator, these instruments are also displayed in a vertical tape format. At the bottom of the tape is the altimeter setting that the pilot has selected. The top of the tape shows the altitude the pilot has selected to bug. This places a small marker next to the selected altitude on the tape to help remind the pilot of an altitude they might be trying to maintain. Immediately to the right of the altimeter is the vertical speed indicator. Instead of the tape sliding up and down like the previous instruments, the black marker instead slides up and down to indicate the current vertical speed. Unlike the round dial version, this instrument displays the vertical speed almost instantaneously. The bottom of the screen is home to the heading indicator, although, in this case, this instrument is referred to as a horizontal situation indicator, or HSI. An HSI can be thought of as a heading indicator with an additional navigation capability displayed in the center. Like the round dial, the compass card spins around to show the current heading. A numerical display is also shown above the dial to give an exact heading readout. This instrument also contains a bug, so the pilot can set to remind them of what heading they might be trying to fly. The only instrument not being displayed similar to its original method is the turn coordinator. The G1000 splits this instrument into two separate components, the slip skid indicator and the heading trend vector. The slip skid indicator, also known as the brick, is displayed as part of the attitude indicator. Just like the inclinometer, this brick slides left and right of center to indicate which rudder pedal needs to be pressed to get coordinated. Standard rate turns are accomplished with the heading trend vector. This is a magenta line traveling around the top of the HSI and tells the pilot what heading they'll be at in 6 seconds. 2 tick marks on each side indicate standard rate and half standard rate turns. The MFD, on the right, can be used to display a wide array of menus and features. However, its main purpose is to display a navigational map of the area surrounding the plane. While this map is not an approved method of actually navigating, it greatly aids the pilots in being aware of their surrounding area and any traffic that may potentially become a hazard. On the left side of the screen contains the aircraft engine gauges and other aircraft system gauges. The gauges are split into multiple pages, with the most vital one shown on the main screen. Now that we know what we're looking at, let's talk about how the system works. As we previously talked about, the system is made up of various individual components, each with a specified task, all connected together and working in unison. While the exact science behind how these components work is proprietary, we can cover what the purpose behind each component is and the basics of how they work. This lesson, however, will only focus on the components related to the flight instruments. First on our list is the air data computer. This component works with the pitot-static system to calculate our airspeed, altitude, and vertical speed. Instead of the instruments calculating the information themselves, the pitot tube and static port pressures are sent to this computer to be measured. The computer takes those measurements, makes the necessary calculations, and sends the outputted airspeed, altitude, and vertical speed to the screen to be displayed. The computer also connects to an external thermometer, called the outside air temperature sensor, to calculate the true airspeed. The gyroscopic instruments of yesterday are now powered by the Attitude Heading Reference System, or AHRS. Instead of gyros, the system uses steady-state sensors, much like those found in video game controllers, to sense any changes in pitch, bank, and yaw. Connected to the AHRS is a magnetometer, which is like a digital version of the magnetic compass. This allows the system to find magnetic north and prevents the pilot from having to periodically resynchronize the heading selector with the compass. Today's flight instruments are incredibly reliable. However, as part of a FAA certification, aircraft must still have backup round dial instruments of the airspeed indicator, attitude indicator, altimeter, and magnetic compass. In case part of the G1000 fails, the respective round dial instruments then become your primary source of aviating.